Hello and welcome back to High Level System Design series, where we are discussing all the important concepts for your high level system design interview. Today our topic is design a web crawler. We will first understand what is the purpose of a web crawler, and then in this session we will design a scalable web crawler system which can crawl a significant amount of data per day. A web crawler is a software system which takes few URLs, save the information present in the URLs, extract other URLs from the web pages, and recursively process the new URLs. So we start with some important URLs, also known as seed URLs. It processes all the web pages of those URLs, save the important information, extract URLs from those web pages, and again recursively go to those URLs, fetch information, extract URLs, and feed into the system again. Hope you have understood the working principle of any web crawler. Now the question is, what is the purpose of a web crawler? A web crawler used in search engine indexing, web archiving, web mining, and also for web monitoring. Search engine indexing is the key for any search engine. Web archiving used to preserve data. Web mining to preserve knowledge from the web. Web monitoring is very important for copyright analysis and trademark analysis. Hence, web crawler is an important component in our World Wide Web. Hope you have realized what is seed URL, how we extract other URLs which are related to the seed URLs, and what is the purpose of a web crawler system. With this basic information, we are ready to design a web crawler. Now we will analyze few of the clarifying questions to understand the requirement of our system. Based on the use case, the design of the web crawler may vary, and that's the reason understanding the requirement is a key for any high level system design. And asking few important questions can help us to understand the requirement clearly, such as, should we save or persist the web pages? Should we crawl only the HTML pages, or should we check the documents and PDFs as well? What to do with the duplicate contents? How many pages we have to crawl in a day? These are the few very important queries what we have to clarify to understand the requirement of our system. Let's assume for our use case, we want to save the web pages. We want to only crawl HTML pages. We can simply ignore duplicate contents, and our target is to crawl 100 million pages per day. With this requirement, let's analyze the back of the envelope estimation to understand the scale of the system we are trying to design. We have to process 100 million pages per day, which is 10 to the power 8 pages in 10 to the power 5 seconds. If you are not aware how I am converting 100 million pages to 10 to the power 8 and a day to 10 to the power 5 seconds, you can watch my dedicated back of the envelope estimation video. It's a very easy concept to understand. So nearly 10 to the power 3 or 1k pages we have to crawl per second. As we have to persist the web pages as per our requirement, let's quickly estimate the storage requirement per day. If we assume average page size is 1 MB, the total storage requirement per day will be 10 to the power 8 into 1 MB, which boils down to 100 TB per day. Once we have realized the scale of the system we are trying to design, it's time to start with very simple design of our system and then understand what could be the potential issues with the simple design, and then gradually refine the design to some extent so that the system can handle large amount of load, such as it can crawl 1K pages per second and it can store 100 TB of data per day. User passes some seed URLs initially to the web crawler server. Let's assume for simplicity we have only one single server which takes the seed URLs. What it does, it takes one URL at a time and download the web pages from internet and save it in a database. It also stores the URLs present in these web pages into a separate database, and then our web crawler server takes those URLs which were present in the web page content and further crawl to those web pages, and the process goes on iteratively. Now let's analyze few issues of this initial design. It has a single server which is single point of failure. The single server has multiple responsibilities such as download pages, duplicate content checker, URL extraction process, etc. So our design is violating single responsibility principle. Hence, the initial design is not the way to go. We need some better design where we will keep different server for different responsibilities. In this design, we have separate web page downloader server whose responsibility is to download the web pages from a collection of URLs. Once it is downloaded, duplicate content checker servers will check if the content is already present in our storage or not. If not, then only we will save it in the DB. If it is a duplicate content, as per our requirements, we will ignore duplicates. So we will not save that content into our content database. URL extractor read the content from the database and extract URLs, save it into the URL DB, and our web page downloader will refer to those new URLs for next iteration. However, initially, as we know, we pass some seed URLs to start the crawling. The benefit of this design over our initial design is it has single responsibility for each and every servers. So one single server will not be overwhelmed with a number of responsibilities here. Now let's understand what kind of DBs we need to use for our system. Our system is write heavy because we have to store the content of 1K pages per second, and as every day we will be dumping 100 terabyte of data, obviously we cannot use RDBMS or relational database. We have to go for NoSQL, and as we will be storing HTML data, it's better to use some document database for our content DB. If we think about URL DB and if we assume 10 URLs per pages, every second we will be storing 10K URLs. For this also we need NoSQL, and key value store will be a good choice for our URL database. Hope you have realized how we are concluding and choosing a very specific type of database for our use case. As we need to also perform duplicate content checker, it's a good idea to keep hash or checksum along with the content of the web page, so that in future it would be easy for us to compare and check if we already have the content in our storage or not. The same goes to URL DB as well. For URL DB, we can keep hash as key and URL as value, so that it would be easy to identify if we have encountered any duplicate URL or not. Hope you have realized how we have chosen the database and why we have to perform hashing and checksum for a web page content. There are few additional points we have to discuss when we are designing a web crawler system. One is politeness, second is robot.txt. What are these things? What are these politeness and robot.txt? Let's first understand them and then we will try to incorporate them in our design. When we parse a web page and fetch all the URLs on that web page, there is a high chance that all of those URLs will be from same domain. For example, if we are parsing a web page of a specific institution like Harvard, most of the URLs of that web page will also redirect to the same domain of Harvard University. Hence, if we crawl continuously, too many requests will go to the same domain, and obviously the domain can rate limit, assuming a denial of service attack. To avoid this, we have to be polite while crawling their web pages. Politeness is a process through which we can avoid rate limiting or assumption of denial of service attack. What we have to do? What is the solution to keep our web crawler polite? Solution is based on different domains. We segregate the URLs to be parsed, and we can keep a client side rate limiter to ensure that in a particular time interval only very few requests will go to domain 1 and then few requests to domain 2, few requests to domain 3, so that in a particular time interval there will be very less number of requests will go to a very specific domain. In that way, our web crawler system can ensure politeness for crawling the domain. Hope you have realized the importance of keeping our web crawler polite. Now, what is robot.txt? Robot.txt is a file always be there in the web server of our target web page, where it defines which are the web pages we can download from this web server and which are restricted for downloading from the web server. So by reading robot.txt we can understand what are the web pages permissible to download. Remember, we cannot download the pages which are restricted as per the robot.txt file. That will be unethical if we download those pages. Apart from this, we also consider the priority of web pages, because few web pages will be of less priority than others. Based on these additional points, let's refine our design one more step, where we will add a new server for frontier service. What it will do? It will ensure politeness, priority. It will check if the web page is permissible as per robot.txt, and then it will pass the URL to the web page downloader. Remember, web page downloader consults with DNS to get its server details in order to download the web page from the server. We will have dedicated server for duplicate checker, and if it is a unique item, then only it will be stored within a distributed NoSQL database to store the content. We will have URL extractor which will take the content and extract URLs out of it. We also add some URL filter, because in reality there are many URLs which will not be reachable. Few URLs will be of no use, or some sensitive information is present in those URLs. Those URLs we can drop with the help of URL filter, and then we keep the clean usable URLs into a NoSQL DB which can store key values, and finally those new URLs will go to the frontier service again. Initial starting URLs will be seed URLs given to the frontier service. Hope you have realized what is the importance of this frontier service. It is responsible to keep our web crawler polite enough so that our requests will not be blocked by the web servers we are trying to fetch web pages from. We also apply few of the priorities in order to crawl the important URLs first. We also add here robot.txt file with the help of frontier service. Let's think about the performance of this system. Web page download is a time consuming task. Question is how to enhance performance. We need performance for our system because from the back of the envelope estimation, it is very clear that we need to handle or parse a large number of web pages, which is 1K pages per second. So obviously our web page downloader has to be performant enough to match the requirement. Apart from this, we can have some filtering rules in order to filter the URLs. Let's have the final design for our system, where we will have frontier service which takes seed URLs. What frontier service does? It segregates domain specific URLs in order to maintain the politeness of our web crawler and place some rate limiter to it. Based on this, few URLs will go to the web page downloader, which is a service responsible to download web pages based on the URLs it gets. Here in between we can have some Kafka queue which makes this system asynchronous. So frontier service, based on the politeness and the priority, it fills up D1, D2, D3 queue. Based on the rate limiter service, few of the important URLs will be placed within the queue in order to make the system asynchronous, and web page downloader will fetch the URLs from this queue, consult with DNS in order to get the IP address for the web server, and keep the metadata into another queue. From this queue, there can be a number of workers responsible to download the web pages and pass those web pages asynchronously to the duplicate checker. Duplicate checker uses checksum and hash to understand if the page is already present in our system or not, if the content is already present in our system or not. If not, it stores the content into the content DB. We will have URL extractor. The server takes the content and fetch URLs, which goes to the URL filter. URL filter consults with rules database and filters the URLs accordingly. And finally, the filtered URLs will again feed into the frontier service. Hope you have realized from the initial design with a single server how step by step we have made our design better. And finally, with the help of queues, we have developed an asynchronous high-level system design for a web crawler which will be performant enough to parse 1000 pages per second. Let's summarize the session now. We have discussed what is web crawler and what is the purpose of this system. In other words, why web crawler system is important for search engine optimization, web archival, web mining and web monitoring. We discussed few questions in order to understand the requirement and use case for our web crawler. We analyzed the scale of our system with the help of back of the envelope estimation. We designed our initial design with a single server that was responsible for downloading the pages, duplicate content checking, URL extraction, etc. And we soon realized that single server is prone to single point of failure and we are violating single responsibility principle. We segregated the responsibilities among multiple servers. We discussed about the type of databases we need for our purpose. We discussed few important pointers for web crawler system such as politeness, robot.txt and priority of the web pages. We realized why frontier service is very important part of our web crawler. In order to enhance the performance, we have added multiple workers for downloading web pages from internet. We added few queues so that the components of this system can work asynchronously. Hope you have enjoyed this session. If you have learned anything new, do not forget to like this video. I will be adding few more high level system design videos in this channel, so do not forget to subscribe this channel. Thank you for your time.